Good morning, Math 201 students, on this wintry day, shall we say. Well, I'm sorry that we have to miss class today. I really don't like missing class at all. I don't know about you, but anyway, what I'm going to go over in this first video, it's just finishing up the work that we were doing from last week, actually week before, on limits that fail to exist. So think about all the graphs we've drawn and the functions that we've been studying with tables. I'd like you to think about, when do limits fail to exist? Draw or list 3 situations. Here, I'll give you some time. Okay, well, hopefully you thought about jumps in that time. That's one thing. If we just draw a graph here, we can figure out a situation. I'm just going to make up some numbers here. Let's just call this function f of x. And suppose we have something that looks like this. I'll do something kind of easy. And then maybe something that goes like this. So this might be at, let's call that 3, just making up numbers here, and then this could be at a height of 2. All right, so what we notice in this case then is that we see a jump, right? A limit doesn't exist. The limit from the left would be at a height of 2. The limit, the y values that f of x is approaching as we approach 2 would be 3. So jumps are an obvious one. I don't know if you thought of any others, but we could also have vertical asymptotes. And another kind of behavior, it's called oscillating behavior, that we're going to study in this next problem. All right, so what I'd like you to do now is to take out your calculator, and I'd like you to put cosine 1 over x in your calculator, and then go to the table and we'll take a look at these values, and we want to figure out a pattern that we observe. Okay, well, I've done that. So just some things to point out. I'm using my TI-84 Plus. Make sure you're in radian mode. And then you're going to enter in the function cosine 1 over x. Next, you want to go to your table setup. Remember, you press second window. And you're going to put your independent variable, which is your x variable, in ask mode. Now I'm going to just start entering values after I go to the table, which is second graph. I'm going to start entering values in. This first value is 1 divided by 2 pi. Make sure you put the 2 pi in parentheses, and then it outputs the y1 value. The next one is 1 divided by 3 pi. Again, put the 3 pi in parentheses. And we're noticing this pattern of values that we get. Hopefully you're observing that it's alternating, right? Or what we say in math, it's oscillating between a y value that's jumping, right, from 1 and negative 1. All right, so I'm just going to go back here. We're just going to write the pattern, that we observe. So we'd say the h of x values jump or oscillate between negative 1 and 1. All right, the next thing we'd like to do is, in our graphing calculator, input this window, and then let's see what we can conclude about the limits from the right and the limits from the left. Maybe just by looking at the graph, we might have to go back and modify the table and to see what we can come up with. So remember, you're going to put this, the way we write this is x min, x max, and that's x scale, and then y min, y max, y scale. don't forget to put a parenthesis around 2 pi. Otherwise, your calculator will do a different order of operations. Okay, so what I've done is now I'm showing you the window that you should get. And then press graph and you'll see the graph. So we can see what's happening here. Right now, we're just looking really to the, I'm only interested in looking to the right as we approach 0. So 0 is right here. And I'm looking at what's happening to these y values, right, as we approach from the right. Well, they're not really honing in. We don't see a pattern where it's approaching a single value. Even as we get really close, it just keeps jumping up and down. So we can see in this case, it's a special case, that the limit as x approaches 0 from the right of h of x does not exist. Okay, we know that in order for the limit, the overall limit, to exist, we would need the limits from the right and the left to be the same and to exist. Since we have one of those limits that doesn't exist, we can conclude that the limit as x approaches 0, the overall limit, also does not exist. At this point, I feel like asking any questions, but I can't hear you. So anyway, let's move along. All right, so here's just that problem. Now what I've done is, just for you, I've done it and I've zoomed in even further. So if that previous work didn't convince you that, well, maybe it, it looks like it's oscillating between 1 and -1, but what if we get really, really close to 0? Well, you can see what's happening. As we get really, really close from 0 from the right, it still just keeps jumping, right? Positive, negative, or it's just in a different pattern, okay? So we can't, we want to make sure you don't incorrectly conclude that it approaches -1. That's not true, because all of these values should be approaching the same value. And if it did approach -1, it would be like -9, -0.99, -0.999. Right? So just keep that in mind. All right, and here you can see a pretty clear graph of what's going on. Right? So as we look at shorter and shorter intervals, right, as x approaches 0 from the right, we see it doesn't exist. All right, so that's one example where limits don't exist.